My name is Francisco Barcelo. I'm leading the commercial team for the microgrid LOB in the Schneider Electric, and I would like to talk today about how are we helping the decentralization with the microgrid solutions. First, everything we talk today is about the electricity 4.0 is how we call in Schneider Electric the sustainability axis that is formed by the digitization and the electrification of the grid. And this electricity 4.0 is impacting across the whole grid, from power generation with new ways of managing the assets in the power generation, in the traditional power generation. Of course, with the renewables power generation, that is also changing the way the grid has to be managed, impacting, of course, transmission and distribution, and eventually with the new players, the prosumer. That is what we are going to talk a little bit more today. The new energy landscape, from how the prosumers are acting in this new energy landscape. Well, I'm sure you have seen this many other times from the traditional energy value chain, that it goes in one only direction, that it was based on traditional power generation sources and or fuel standalone generation. We are now in a bidirectional flow with much greener power generation everywhere, but also with different transmission and a distribution that has integrated all these new elements, not predictable power generation, and also having to deal with the different impacts of this renewable integration in the distribution part. What is also moving from the medium voltage to the low voltage, all the management of the grid stability, and the biggest investment that we are going to see in the future in the grid will come in the low voltage piece. And the most important and new player that is coming in the new energy value chain is the prosumer. And the prosumer are having new challenges in terms of how can they manage the distributed power generation in their own assets, and how can they integrate this power generation to the distribution. All of that moved and driven by these energy transition drivers that I just put on top of what we have talking, just to complement the message. These energy transition drivers are coming from, first, the decarbonization, that is achieving the net zero CO2 emissions by 2050 to ensure that we are not going above the 1.5 degrees in the average temperature for preventing the climate change. We are also, as a second key drivers, the electrification of the uses of the energy usages, because we are all seeing that the best vector to handle the energy is the electrification, that helps us to manage much better all the power usages. And this means that we will have worldwide plus 80% versus the electrification we used to have in 2021. Same thing about the renewables, where we are seeing 3 times more renewables to ensure that we reduce the footprint of the power generation. And as you all have seen during the last year, we have a much greater scarcity and volatility of the prices of energy. We have all suffered that early last year, and even though now the prices are back to more regular prices, we can see, all of us, that this will happen some moment in time later, and the volatility of those prices are much greater now. On top of that, scarcity with the congestion of the grids in many countries across Europe is also needing or promoting the needs to answer that. And I have not put this in this slide, but it's important to mention that all these energy transition drivers, are also complemented by the need to invest in the grid twice the speed of what we have been investing until now. If we are not able to invest in the grid at the double the speed, we will not be able to absorb all the challenges that the grid is facing due to the renewables, prosumer, and challenges we have in the low voltage, etc. I was mentioned before. All of these energy transition drivers are solved, or we want to solve them with decentralization, with demand-side flexibility, and I will talk a little bit more about it, and without losing the energy reliability that is so important for us in Europe that some other regions in the world doesn't have. And we don't want to lose it. How do we do that? We do that with the technology that the Schneider Electric is proposing is the microgrid solutions, where we propose this technology or these solutions in different axes. First, from the technology standpoint. Before that, what is a microgrid? Well, just a quick reminder, a microgrid is a group of interconnected assets that works as one single entity, managing local distributed generation and local loads, variable loads, and that we can handle to optimize the complete solution of this microgrid. And what the Schneider Electric is proposing with these solutions, as I said, this is twofold. On one side, from the technology part, we have implementing a solution based on 3 layers in the architecture that we call EcoStructure, where the microgrid composes of the connected devices that we need really to get everything in the field connected to be able to manage it. And this is through the digitization, as I said before. So every single device, from power generation, from consumption, has to be connected to be able to handle it in an efficient way. Second layer in our microgrids is about the edge control. This edge control is real-time for on-site management of these loads. And it's real-time because it's managing about the power management system. The power management works in real-time to ensure the balance of the power generation and power consumption, sharing loads, or adapt the settings of some loads to be able to handle the balance. And a third layer where we have the energy management system. This energy management system is the real jewel of the crown, where we optimize the microgrid consumption, and we do that in the cloud. So the energy management system in the cloud is connected to the edge control, setting the optimizing of the optimal points, the optimal settings of this power management system, and it does that every 15 minutes in a non-real time, but setting the next 24 hours optimized settings for the power management system, and every 15 minutes is recalculating the next 24 hours. Why? Because the reality can change during from time to time. So every 10 to 15 minutes, depending on the load of the cloud, it optimizes the setting of every site and set the points to the power management system to handle for the next 24 hours in case of a loss of connection, or in case of any unpredicted situation. The power management system takes the control and handle the whole system until having the connection again to the energy management system. This is the one side of the microgrid solutions we propose from the technology standpoint. Of course, this third layer is based on artificial intelligence, trying to optimize from the learning with machine learning architectures to from the consumption of the different elements to optimize that permanently without man intervention or people intervention. And on the second fold, I want to mention is that we are democratizing the microgrids. How are we democratizing the microgrids? Well, until now, and it's our experience, we are doing microgrids in project mode. This is what almost everybody is able to do, with some strong investment in in people, some strong investment on time to develop a microgrid. Every single microgrid is unique because we develop everything for this microgrid. What we have been working during the last 3 years is to standardize those solutions. And we have already launched this year in US the Microgrid Flex solution that intends and will standardize and democratize the microgrid, because with this new approach, that is Microgrid Flex is the solution that will help the eco expert to take some bricks from our catalog, and those bricks will be are designed to be part of a standardized TVDA, what we call tested, validated, and documented architectures. And from the solution that is needed for the customer, they will replicate what we have already tested in our lab to have a much simple plug-and-play solutions. And in this process, they have tools that help to design the microgrid, to implement the microgrid, and to operate the microgrid. So there are 3 steps in the microgrid implementation, starting by the design, where they have a tool that enables to identify the best battery balance for the consumption. If we need more PV or in the design, or we need more batteries, or we need more power from the electrical control center. And from that design, we have an implementation tool, and the implementation tool will give automatically the software that has to be implemented in the power management system and in the energy management system. And then the eco expert doesn't need to create the full algorithm or the full logic for the site. Is automatically come from the software of the design in the previous step they have used, and eventually the EMS and the PMS are the operating software that will use what we have defined and implemented in the microgrid. So what I said at the beginning is that we are doing a twofold approach. First, from the technology standpoint, with these 3 EcoStruxure layers I was mentioned, and a second, from the democratization of the solution, standardizing the packages for enabling our eco expert to do much more and much cheaper competitive solutions in the microgrid. This is how we do approach the microgrid solution, and this is, at the end of the day, to deliver these integrated outcomes. First, energy cost optimization, because on site you will be able to decide what is the best source to get the power for your consumption. Resilience is not that important asset in Europe, but it's very important in many other parts of the world. And in Europe, instead of resilience, we can provide what I mentioned before, solutions for congestions in the network, because if there is no additional power, we can do local power generation to help those consumptions to be made. And sustainability, of course, thinking about integrating the best balance between renewable sources versus any other kind of potential sources. And this is how do we provide the microgrid, and on top of that, it's a win-win approach, because that provides flexibility to the grid. The prosumers are able to provide flexibility to complement what the utility has to handle for integrating the full set of renewables. How? Of course, we have to do that due to some programs from the government to enable flexibility, both capacity, flexibility markets in capacity of frequency regulation. But this will be part of the regulator role to enable this market. And in this win-win approach, in the flexibility to the grid, the microgrid can help to solve the flexibility in the grid. And these are, as I said before, enabling that the solution will not come only from the utilities. With increased requirements to be more sustainable, with growth in on-site DRs and renewable storage, grid flexibility in connection technology, or grid capacity growth, and the other 2 we have here. And last, to conclude, the value of the demand-side flexibility provide 3 major benefits from the grid, and it has grid optimization on top of cost-effective grid services. For the customer that implement the microgrids, they will have improved energy efficiency, because these solutions will not only allow them to be more sustainable using greener solutions, but also to have a better energy efficiency in the management of the different loads with the PMS, with empowered consumers that will decide by their own how they want to use the different source, and of course scalability, enabling through the eco expert, as I said before, install many more microgrid in the market. And for both grid and the customer, increase renewable energy integration and reduce carbon emissions. That was, at the end of the day, the initial goal we had for improving the sustainability. What have we to do to make it happen? As you can see on the right side, we are already working, but we need to keep working on advanced artificial intelligence for solutions and to implement the better BSS technology. As we can see in Europe, batteries are not yet deployed at the right speed, so we will need to keep working in better battery technology to simplify or reduce the cost, to enable a better integration of the battery that opens all the use cases for the microgrids. So artificial intelligence already in place, but many more to come, and the storage technology has to be developed to enable more integration of those batteries. We have to work on regulation and policy, because today in Europe we have not flexibility markets enough to enable microgrids. In many countries we have flat tariff, we have no ancillary services open for the customer, and all of that is preventing more integration of the prosumer well, and we need the policymakers to change that. We are seeing some steps in the right direction, but we need more speed to enable more microgrid and prosumer in the future. Same thing for the standardization. We are working, and I was explaining you before, on a standardized solution with predefined architectures, helping to implement them easier for the customer. But we have to keep working on that in the future to help for a more and greater integration of those microgrids. On the right side, you see the upskill of the workforce, not only of the workforce of our own companies, but the full value chain. Our eco-expert is how we call our specialized partners, has to develop competencies to be able to integrate the microgrid in their solutions. In the past, we used to work much more with eco-expert working on electrical distribution hardware, panel builders, copper, switches. Now, every single installation is digitized, and you need to complement the competencies of your team with software competencies, with communication competencies, in order to enable this installation to be installed. We have to develop an easy and make easier the financial model that enables the energy as a service players to work more and more. Why? Because we want to accelerate the implementation of these prosumer solutions, and the CapEx investment is huge. So we need financial entities helping in energy as a service model to help the customer to use more and more microgrids. And eventually, we also need new roles in the value chain. And these new roles, not only about better specialization from the installers and eco-expert I was mentioned before, but also new roles in terms of aggregators, that once the policymaker enables them to access the flexibility market, will be able to integrate the different prosumers in bigger entities to provide virtual power plants or any other kind of services to the grid. All of that are elements that we are working, but we need to keep working in the future to enable the flexibility in the demand side of the grid. I will stop here, and this is how do we see the evolution of the microgrid.